Okay, so let's talk about beginnings. You got the website there, and I am speaking, but this is a consortium, and I serve currently as the leader. Tom Defy, who you heard from yesterday, is deputy director, and then we have a number of other PIs for various regions. And in addition to that, we have biotechnology and pharmaceutical partners who are full partners in this and part of the governance of this project. Next slide, please. Oh, I control the slides. Okay, we do not want to duplicate what you've heard. Why would we? There's no need for yet another study that does the same stuff. However, we want to be a catalyst. It's very clear that this is a transformation of pediatric healthcare delivery, and to be done right will require a massive investment and a very large number of participants. The very large number of participants is driven by two very simple factors. Number one, we are racially, ethnically, and ancestry-wise diverse. And this is not a one-size-fits-all. It needs to be attuned to your background genetic architecture. And that means we need hundreds of individuals, thousands of individuals from each of those groups. So 1 million is a minimal number. Second of all, we are dealing with 10,000 diseases. Now, not all of them are ready for screening, but we need to have a vision that we're going to cover diseases that have a very low incidence. 1 in 50,000, 1 in 100,000, 1 in 250,000. Again, only by having millions of people participate can we actually identify information related to the natural history and the screenability of those conditions. So this is our solution. And let me stress that our goal is not necessarily to do, it's to catalyze. All of these groups are doing amazing things. Our goal is to accelerate and catalyze, right? And we have a vision that is going to, God willing, solve a major problem for rare disease families globally. And that is, how can we optimize outcomes? How can we minimize the pain, the suffering, and all of the constant burden of obtaining healthcare for your precious baby, then your precious child, then your precious teenager throughout the lifespan? Can we really solve that problem? Modern medicine is broken when it comes to rare disease. Modern medicine is incredibly effective when it comes to common disease. It's built around common disease. We need a new healthcare delivery system for rare disease. That's what we propose. So, of course, it starts with a screen, and we're going genome. But in addition, and driving this is point 3, we've got to focus on the interventions. We've got to make sure those interventions start early enough to change the outcome. And then we have not done society a great beneficial action unless we really focus also on 4 and 5. 95% of the diseases that we diagnose in babies do not have effective therapies. And furthermore, of the remaining 5%, there's probably only 0.5% for which they are fully effective or curative. So children, even with diseases like phenylketonuria, still have a pretty tough life with complications. And then lastly, we really are thinking about solving this healthcare delivery system on one of this, on an iPhone or a cell phone. That's a lot, isn't it? Okay, why? Why are we doing this? Well, for 10 years, I have focused, my team is focused, and now groups worldwide, including many who are represented here, have focused on diagnostic genome sequencing. Same technology, same remit, except it's diagnosis, not screening. What we found is truly amazing, which is this really works. We identify these diseases and we change outcomes. But we have a major problem, and that is these kids are already in an intensive care unit, and in many cases are in organ failure, and in many cases are close to death. Can we move that back to them being pre-symptomatic? Very simple, but predicated on all of these learnings. Furthermore, we know that the trick with making this be implemented nationwide and worldwide was cost effectiveness studies, showing Medicaid medical directors and private payors that this would actually save them cost, net cost savings. This has to be wrapped into what we do if we want it to be implemented in the real world. The final reason why we have to do this is that this is the current reimbursement map in the United States after 10 years. Only 6 states have Medicaid policies. Only one major national payer, Anthem Blue Cross Blue Shield, has a policy and a reimbursement strategy for this. And furthermore, only 1 or 2% of the babies who would benefit are actually being prescribed this intervention by their MDs. Universal screening at birth is going to be the belt as well as the braces of diagnostic genomes. Isn't that cool? Okay, if we're a catalyst, how do we catalyze? Well, the first thing is you gather the best brains on planet Earth. And this may shock some of my colleagues. They generally don't live in academia. They generally live in industry. And so our industry partners are critical. Both drug developers are developing innovative medicines and have this very practical problem. How do I enroll 20 subjects in less than 5 years for my phase 3 trial? Or I now have approval, I can't find the patients. Or when I do find them, they're already too old to benefit from the medicine I've developed. And then on the biotech industry and the IT industry, and those of you who were here yesterday heard from some of these guys and the remarkable contributions that they are bringing to practical problems, like how do we have a massively scalable database that costs just cents to refresh for every patient who enrolls or every patient who unenrolls? How do we figure out variant interpretation? These solutions are going to come primarily from the biotech and the IT sector. Okay, we've built some bits. So Wendy Chung said this, we're building the plane as we fly it. That is tough to do. It's really tough to do, but we have built some pieces. So the first piece that we built, and I think the crucial pivotal bit, is an assessment of rare disease therapy. Would you believe that this has never been done? That most of the interventions that pediatricians use in children with these diseases have never undergone a clinical trial? That the prescribing guidance is based on case reports and case series? So for 2 years, Alexion and our institute partnered to build out a systematic way to fix that, to build act sheets for every single condition. And not just to say this is an effective intervention, but for whom and when and how effective is it and what's the evidence backing up that. Now this is unending, it'll have to continue forever. Right now it has 1,500 interventions mapped to 450 diseases. It's a great start, and this is so critical. The idea of screening without having this virtual management guidance system, not a good idea. This is freely available for everybody, right? We didn't build this for us. We're a catalyst. We want to gift this to every program. I did that one. Second of all, we developed rigorous auditable methods for scoring conditions. I'm not going to say that we got them 100% right, but it's rigorous and it's auditable. So you can track how each decision was made. And we have a team, a national team, who meet weekly and go through one condition at a time. And does it meet the critical criteria? They were set in 1968. They're not new. I think every group that's doing work in this area agrees on those. So that's also happening. And we want to also gift that process to every effort. Finally, we built a platform. Thank you. This is what I love. I love building platforms. Now, not all of the pieces on this are actually built yet. And in particular, I want to just speak to this one. This is the crucial one. This is what's going to live on this. This will be a parent-controlled platform whereby you, mum or dad, own and control your baby's genome information. And it's dynamic. And it's got all of the resources that you need to help you manage your child's condition, and you opt in and you opt out, and it's not a singular thing, it's on an ongoing basis. You absolutely control what happens with your baby's information. But this really works. Let me just show you that it works. So first of all, what's our comparator? We're going head to head with existing newborn screening. We're not trying to replace it, but we do want to be as good as it. So we've got specificity and sensitivity numbers. Boom, boom, boom. We know that it costs, $196,564 per positive test in California in 2012. So how does this test work? So first of all, we used the UK Biobank, where you should not have a lot of true positives for diseases that cause critical illness in infants, right? That was our premise. And so we looked at 30,000 variants mapping to 388 diseases, and our specificity is 99.7%, meaning that a PPV of 50% was possible. That's extremely encouraging for every group. Second of all, then sensitivity. And we, again, compared with standard MBS, what we found, and this is now predicated on diagnostic genome sequencing. So it's not healthy babies. These are sick babies who have a very high incidence of genetic disease. But within our overall population, this will be the sweet spot, right? This will be at least half of our positives. So it's an okay set to compare with. We had 87% sensitivity relative to diagnostic rapid whole genome sequencing. That costs $8,000. This test will cost about $300. And compared to standard MBS, we found an awful lot of screen negatives that were true positives by standard MBS. So this is our map. As I said, my goal is never to enroll a single baby, but that probably won't happen. We're definitely going to need to enroll in Africa, in Thailand, in Pakistan, in the Philippines, and so on, countries who are not participants yet. We're going to need to do that for them. And you can see that our goal is to reach 1 million as quickly as possible. With that, I'm going to hand over to the first governmental group who have joined our consortium, and Dr. Petros Tsiparas.
Thank you. Good afternoon. So BeginNGS Greece is a non-profit entity that was incorporated with the clear mandate to carry out a pilot trial for newborn sequencing in Greece. And although it has been funded entirely by national philanthropy, we are coordinating, collaborating, we're functioning as part of the BeginNGS consortium that Stephen is putting together in terms of clinical protocol, primary endpoints, and outcomes. So the type of study, and we are in the process the last few weeks, and we met also with some of the groups in harmonizing a protocol that can be submitted to different IRBs. And we are in the process of finalizing this protocol with the goal, at least for the Greek component, to be submitted late October or early November. And we aim to enroll 1,000 neonates. And this is, we are planning to initiate enrollment in 2023. So as part of this, this is obviously a visual of the workflow. And we've heard a lot about educating both the end user, but also the physicians. And we are starting in literally 3 weeks a number of focus groups which will help inform us what is the perception of the user about newborn sequencing, and at the same time help us refine our positioning and messaging when we go for informed consent. The enrollment is going to be done in the 3rd trimester of pregnancy through 3 clinical sites. And sampling will be done at day of life 3, when the babies are discharged from the maternity ward. and will be done in tandem with the standard newborn biochemical screening, which is a national mandate. Of course, sequence and analysis will follow, and we'll be storing the data in an EU server as per GDPR directives. And of course, we're going to have pathogenic and likely pathogenic variants will be orthogonally confirmed, validated, and counseling, genetic counseling and referral are integral part of this process. As I said before, and Stephen also mentioned, this is an example of public-private philanthropic partnership. And we engaged from the very beginning the Public Health Service, which is going to be a sponsor of this study. We are going to be enrolling, as I said, in 3 academic units, which are in southern, central, and northern Greece. And we chose those because they reflect the current demographic, cultural, but also genetic composition of the population. So as part of this process, we have already started some education and with some soft education with publications in dailies, the printed press, but also through the social media, so that we can continue building some general awareness and understanding about newborn sequencing and, of course, screening. Thank you. And Stephen, back to you.
Thank you, Petros. So I think Petros is a great example of what we're hoping to catalyze. We would like to recapitulate this in probably 20 countries. And then in addition to fill in gaps that will exist in US enrollment. And I'm super excited about this. And this is an open invitation for all of you to join us. There's really no downside and a lot of upside. And just sharing of protocol, sharing of knowledge, as well as all of the resources that we're developing through our biotech and pharma sponsors.